talking about something so important that no living thing on Earth can live without it. Give up? Well, the answer also happens to be the subject today at the weather classroom. Air. And lots of it. Here on planet Earth, we live at the very bottom of an ocean of air. We call that ocean the atmosphere, and like all oceans, it's really deep. In fact, it's a lot deeper than any of the watery oceans that cover the surface of our planet. For ages, people have tried to figure out just how the atmosphere works. They've studied it from on the ground looking up, floated up into it with balloons and looked around. And now, we even study it with satellites high above the Earth looking down. Scientists and explorers have risked their lives to learn more about our atmosphere. So we figured the least we could do was send our own explorer, Brandon, out to seek high adventure on the sea of air.
Hi, welcome aboard.
Hey.
Here you go.
This will help with the seasickness, right?
Yep. And don't forget to wear plenty of sunscreen.
Thanks. Adventure on the high seas. Yeah, boy. That's what I'm all about. Adventure. Welcome aboard the good ship Western Union here in Key West, Florida. This place has been a haven for mariners and explorers. And since we're going to explore the ocean of air above us, somebody thought, hey, I've got a good idea. Let's put Brandon, who gets seasick, on a boat and do the show like the ancient mariners would. Which is seasick, I guess. But no matter, I'll be getting me sea legs soon. And besides, we've got a lot to cover, so let's get to it.
For ages, explorers and scientists have tried to discover the atmosphere's secrets, using kites, hot air balloons, airplanes, rockets, satellites, and even lasers to probe its mysteries. What they found is that the Earth's atmosphere is a mass of gases and ever-changing clouds. It's also the main ingredient in making weather. As a matter of fact, some scientists call the atmosphere the weather machine.
The word atmosphere comes from the Greek words, meaning ball of air.
So what's the big deal about air? You can't even see it. And if you can't see it, taste it, or smell it, how do you know if it even exists? That's a good question. In the 1st century AD, a guy named Hero was wondering the same thing. He noticed that if you turn a container upside down and put it straight into water, the water can't go into the container. Why? Well, he figured it was because the container was full of air. But if you make a hole in the top, the water rushes in and the air is forced out. So there's your proof. Air really does exist. Okay, once people figured out that there really was such a thing as air, then they started trying to figure out what it was made of.
Of the mix of gases that we call the atmosphere, about 4/5 is a gas called nitrogen. Nitrogen, or N2, is a very stable gas, so it doesn't react much with other atmospheric gases like oxygen and carbon dioxide. Carbon and oxygen compounds are used by plants, along with water. But nitrogen doesn't play well with others, and that's why most of the atmosphere is nitrogen. The total mass of the air in the atmosphere weighs an estimated 5.5 quadrillion metric tons. That's 55 followed by 14 zeros. Sounds like a lot, doesn't it? Guess again. That's only a millionth of the weight of our actual planet. And it's the Earth's gravity that keeps our thin little atmosphere from floating off into outer space.
But I'm getting ahead of myself. And anyway, I've got to get ready to sail. So let's hook up with Jason, who's been doing a little traveling himself, up into the atmosphere, to talk to the experts about our sea of air.
Got that line, Odell?
Aye, aye, Captain.
This is NCAR. the National Center for Atmospheric Research here in the Rocky Mountains. No place better to study the atmosphere. Come on, let's go inside. Here at this mile-high site in Boulder, Colorado, the NCAR scientists gather data and make observations using satellites, weather balloons, and research aircraft. Then, they take all that information and bring it back in here and use powerful supercomputers to help them figure out what's going on up there.
Here at NCAR, the National Center for Atmospheric Research, we do a number of interesting things that have to do with weather and climate. We study the sun, we study the atmosphere itself and the motions therein, storms. We study the ocean, and we study the chemistry of the atmosphere and how all these things interact. We have to go where the weather is. For example, if we study thunderstorms, we'll go to a place like Oklahoma. If we want to study tropical squall lines, we'll go to places like the South Pacific or the tropical Atlantic or to the African continent. NCAR scientists study the weather and climate in a lot of different ways. We have aircraft, we have supercomputers, we have the High Altitude Observatory where they use a lot of data from satellites and telescopes that are in other parts of the world. The aircraft are used for a number of things. For example, we have a radar in the aircraft so we can fly close to thunderstorms and look at their interior structure. We also have instruments on the aircraft that measure the wind, temperature, moisture, turbulence, and so on. And if the storms aren't too strong, for example, over the ocean, they're not as strong as they are over land typically, we will fly through them. The atmosphere is the weather machine. The atmosphere is a mixture of gases constantly in motion. Those motions get their energy ultimately from the sun, and they take incredibly diverse forms, highs and lows that you see on the weather maps on television, hurricanes that you can see in satellites, tornadoes, thunderstorms, snowstorms. All of these things ultimately go back to the sun, how it heats up the atmosphere on Earth, and how the air moves. We need it for life. We breathe the atmosphere. Plants need the atmosphere. They take up carbon dioxide from the atmosphere. We take up oxygen from the atmosphere, and we couldn't live without it.
Don't go away. The Weather Classroom will be right back.